thank everybody for joining. This is the new format of the TED Talks in which we can expand a little bit more of the content and presentation. Normally we like to talk about 15 minutes. Here we have up to 1 hour. So Jonathan was kind enough to prepare his summary of ideas about Java modularity. Some of them we talk about it in the DevOps conference, and some of the ones come from other, even other conferences. Since he is a real Java freak. So without any more, I'll give it back to Jonathan. Thank you.
Okay, so first of all, thank you for coming. In this presentation, I will try to show some basic concepts about modularity, and especially in Java. But I would like to start giving thank you to all of the people that have helped me doing this presentation. So thank you for your comments. So this is the agenda we'll try to cover during the talk, from the definition of the concepts to going in more detail about some of them, and also comparing the different implementations that I have chosen for this presentation. So if we want to talk about Java modularity, first we should start defining what is modularity, but instead I will start defining what is not modularity, because we have to recognize the differences between them. So the contrary of a modular application would be a monolithic application or system. Considering this presentation will only consider the application, not the entire system. So having the image of a monolith as a single giant block of stone or metal, like the picture. So a monolithic system has different characteristics. So it can be made in only one deployable piece. Also, it doesn't have subcomponents that we can deliver separately. And if we have different parts, those parts are tightly coupled, so we will have a monolith application also. And another characteristic of a monolith system or application could be that its parts don't have existence apart from the other parts, so they need each other to live. Finally, we can end in a monolith application if during the time we have started using the modular design, but we have grown the functionality and interdependency between the parts at the same time, so we will end with a monolith system also. We can treat modularity or not modularity in two different aspects: the compile time and the runtime. So there are different implementations that, and some cover compiling time. Later we will see that Jigsaw is one of them, and others cover the runtime, and we will see that OSGI complies with that. So then, what is modularity? So let's see what one of the descriptions that we could use for modularity. So first, I will describe what a module could be. As we are talking about modularity, we should describe what a module is. So I consider a module as every deployable unit that your compilation will create. And here we have a description about what modularity could be. So it could be a design technique where we invest effort in creating different models that are independent because they can run separately, interchangeable because they work using contracts and we can replace them with other modules, and the system will have to work the same way, and with limited functionality for every module to ease the separation of concerns and the reuse of them. As I said, this is the ideal situation. Maybe reality could not be as ideal, and you can end with a modular design but not 100% the same idea that I have described. So why we could use modularity? Modularity have different benefits, and also we have to consider different drawbacks that can give us modularity. Some of the pros are that it helps to lose coupling because we separate the logical parts of the system into modules, and for that we have to use contracts or protocols to interconnect those different modules. Also, it can help optimizing development because teams can work separately without waiting one team to the other team for finish their code. Also, it may ease the escalation and evolution of the application as we can evolve a single module without touching the rest of the application. And also we can escalate because in some implementations we could end having the same module replicated many times just to accept more requests if we are using a web application. Also, it forces us to reuse modules. Well, we can design in another way, but we should use reusing modules due to the single responsibility or functionality that I have mentioned before. And also, and it's an important thing, it could ease testing because as the interdependencies are low, we can test every module separately without having a big application that could make difficult to test for a certain functionality. But it could have different cons because it adds more tracking complexity because when we have only one module, we only have to take into account one piece of deployable code and only one version. Also, it needs to be more accurate with our code practices to avoid repeating code, to reuse code, and to keep independence between the modules. Also, it forces us to consider more flexibility because as we are using contracts to interconnect the different modules, we can end if we use not a good design for those fences. If we haven't defined good boundaries for the modules, one module could end crashing the system or doing some collateral damages. And also we have to consider that we will end having different kind of modules, and we only have defined a contract, and well, we have to be more flexible to accept different functionalities. And also it may add architecture complexity because the protocols we need to interconnect the modules, runtimes, where to deploy those modules, and we also should have formats to define the modules and the boundaries of them. But modularity can be implemented in different ways, and it has been during the years. These are some of them. The most known for a long time was SOA, that intended to define our system using different web services, in all days using SOAP as the protocol to interconnect the web services and the clients, and also providing different shared elements or common parts that gave security, load balancing, and other system modules that all the web services were sharing. Also, we have microservices that nowadays is very trendy, and it claims to be an evolution and radical improvement of SOA. It depends where you hear, the person that you hear about microservices. where the idea is that you have to split your application into completely independent modules that have nothing, absolutely nothing in common with the other microservices, not sharing even the persistence layer. So the idea is to have a different database for every web service, and also not sharing even the coding language, just to have different remote teams that can deliver or develop different microservices without considering each other. Then also we have two more implementations that are the main subject of this presentation. OSGI as an implementation considering modularity at the compile and the runtime, having a module lifecycle where you can start, stop, install or uninstall every module separately. Service discovery and injection, as you can have different components that are living in the container and can be inserted in other packages, other modules, sorry. Restriction of the visibility for the public packages, as this is a well-known problem with the current system for the Java platform, as you have only public, private, protected, and package visibilities, but you cannot constrain the public visibility outside of your deployment unit. So when you define a package as, or class as public, it's public for every other package outside that jar commonly. So you cannot constrain for which packages or for which modules that class is public or not. And also the ability to, this is an important thing, ability to manage different versions of the same package running at the same time. So you can have a container with different versions of the log4j, for instance, or if you are using Spring, maybe you can end with different versions of the sub-packages of the Spring, and you can live with 2, 3, or any number of different versions of the same package, and it will not cause any harm. And finally, we have the other implementation called Jigsaw from Oracle for the Java platform. The first idea was to modularize the JRE, just because now we are using a JRE that is giant. It has a lot of classes, and although we are only using a bunch of them, but we have to deal with all of them, and especially for small devices that have to have a Java embedded system, so they have to modularize the JRE just to only deploy or deliver a subset of the classes. So I will start talking about the Java modularity considering OSGI, just a little description, as you are all using OSGI, so you know at least some basic features. OSGI was started in 1998, especially to be embedded in devices, what now is called IoT. In those days it was called, I don't know, domotic or whatever. So they created this implementation to have a modular system embedded in devices. We have different implementations. Here we are in NetCentric, we are using Felix, but there exist others. Equinox, that some of the company and a lot of people in the world are using without knowing. Equinox is the container that Eclipse IDE is using to run and to consider all the plugins or bundles. Felix, and also there's another container called Knoblerfish that is mainly created to be embedded in devices. And then we have different layers created over mainly Equinox or Felix that are Apache Karaf, that is an evolution, a container. It comes by default with Felix, but you can change if you want to use Equinox. The difference between Equinox and Felix is are low, so they are mainly they are similar. The problem should be that maybe Equinox can be a release complaining about that. Well, it can install different OSGI release, and Felix can have a different roadmap, and basically there are no differences, so you can choose one or the other. Also, there is a Fabricate. It's a product from Red Hat. It's intended as an integration, also an integration platform, that it includes Apache Camel, ActiveMQ, and other libraries. And NetBinox, it's an evolution or a modification of Equinox that is run by the NetBeans IDE. Actually, OSGI is in the release 6.0. They release a version every more or less 2 years. So this version comes from 2014. Also, in the OSGI, we have that a module is a bundle, and every bundle has its own class loader, and they have also their own life cycle, so we can start, stop, install or uninstall every module separately from the rest. Also, it has a service discovery to inject, as I said before, services that are components or simple classes defined as a service in other bundles. If we are using declarative services, this will be the way to inject also services created in the same bundle, but there are other ways using Blueprint, that it's another method, and then you don't have to have services in the same bundle to be injected in another component. But also it has more power than declarative services, but declarative services are more they are easy to use compared to Blueprint, and also they don't have XML files. Also, we have dynamic loading of the bundles, of the services, sorry, because we can start the services whenever the bundle starts, or this would be the eager activation, or we can define the service as a lazy, and it will be activated whenever another component, another OSGI managed class requires that service to do something. Also, the file used to define the boundaries of the packages is the meta-inf file that we all have in our Java apps, but we haven't used this file barely never. Also, as I said, OSGI has been used in a lot of applications. Eclipse IDE is the most common. Also NetBeans IDE. but other applications, Glassfish as an application server. Wildfly is the JBoss, Red Hat JBoss application server, and also our product Adobe AM, just because AM is using a Sling that comes installed in an OGI container. Then I will talk about Jigsaw, the other product that comes from Oracle. Well, it started to be adopted or accepted in JCP in 2014, so only 2 years from now. So it's quite new, considering the adoption, but not considering the idea that goes far from that. Now it's in early access. It's not published in Java 8, and recently has been moved to be in Java 9, that will go live in next year. But we have to be watching that, because Mark Reinhold, that is the chief architect of the Java product, maybe he will delay again the release of Jigsaw. Okay, Jigsaw has explicit declaration of the importing and exporting modules. So every module that you create will define explicitly which modules it will be importing and which packages it will be exporting. It uses the module info Java file, so a Java file to define the module that will be compiled in a class file as the rest of the Java files. Obviously, module names must be unique and does not cover module versioning. So Jigsaw is not intended to cover versioning at all, so we will face exactly the same problems as we are facing now if we have different versions of the same package in the class path. So it's not fixing that. Also, it will include a new artifact format, JMod, that will include all what is related with a module. So there we will include jar files, config files, and documentation just to deliver modules as a package.
Did they say why they didn't include version?
What?
Did they say why they haven't included version?
Mark only answers that is not, they don't have the intention to cover that. Jigsaw project has been criticized a lot for that, but I think that Oracle has its own ideas. Okay, so this is a graph that represents the module dependency in Jigsaw. When here we have two different modules, our modules, that our config app module is exporting the API package, but not exporting the report package. And we have another module that depends on the app module. Our app module depends on Java SQL, and Java SQL is depending on Java logging, and finally Java logging and all the modules in the Java Jigsaw product will be depending on the Java base. Well, dependencies are not transitive, so if you depend on another module, you will only see what that concrete module is exporting. So you will not see anything for the modules that your module is requiring. So in this case, our module app will see what Java SQL exports, but will see nothing from Java logging or Java base. For that, Jigsaw gives a mechanism to create transitive dependencies I think that in the end, a lot of people will use this as default, so all modules will be transitive dependency, transitive dependent between each other. So in this case, Java SQL will depend on Java XML, and also it will create that dependency as public for the outer modules. So in this case, our Confu app module will see what Java XML is exporting. This is what a module specification looks like. It's a simple file, a Java file, as I said before, where we define requires as the mechanism to define the importing modules. The requires uses the module name. Jigsaw proposes us to use the same naming convention for the packages to be used for the modules. And so here we are requiring the bus module and exporting our alpha package, also exporting our beta package, but constraining the modules that can see that beta package. So we are constraining the public visibility. This OSGI doesn't have. Also, we can provide services. Just because when we have a data service, the Java system scans all the class path, finding classes that implement the service. But using Jigsaw, that will no longer will be possible. So you have to explicitly define that you are providing a service and the interface that is complained. Also, you can define what the services that you are using with the user's word, and also, as I said, as we saw before, we can have a dependency and making it public, and this is the way, using the requires and defining it as public. So every module that imports our Confu bar module will see also all what COM SLF4J will be exporting. If not, they will not see anything from the logging framework. Now I will try to compare some characteristics of the two implementations. So Jigsaw have dependencies at the module level, and in OSGI you have dependencies at the package level, no matter how it's called the module or where it is the module. Because in some cases you can use, I don't know, if you are using Apache Caraft, you can use Cellar, that is a library, to have different Felix containers in a grid, and you can distribute your services and your bundles in that grid. And for the consumer, that will be transparent, and you will be injecting a service that is a class implemented in a bundle that is living in a container outside of your container, and it's in a remote machine. Also, Jigsaw is version agnostic, so only one version is allowed. In some cases, if you have two different versions of the same module, you will end the same package. You will end with an error, and in other cases, you will end just using the first one that the JRE founds in the system. Also, Jigsaw doesn't have lifecycle management because Jigsaw is intended to cover modularity at deployment time. OSGI doesn't have constraints for exporting packages. So whenever you export a package, it's exported for everyone. But Jigsaw covers that, and you can filter who can read your exported package. And also, Jigsaw is it's defined as covering static modularity at deployment. And OSGI, you can have dynamic modularity at deploy time and also at runtime. So the presentation doesn't cover more content, but I wanted to show or to give you some references in case that you want to know more about modularity. First, I introduce some of the people that are blogging so often about OSGI in the first row. The main person is Peter Kriens, that is running the OSGI Alliance. Also, Neil Bartlett is another one. Those two guys are also defining what BND tools are. So they are managing one of the bundles that we are using a lot. Also, we have Paul Baker that also blogs a lot about OSGI and has a framework called Datu that tries to ease the creation of modular applications using OSGI. Jean-Baptiste Onofre, that he is the PMC of the Apache Karaf project, and he contributes a lot to the Karaf project also, and Camel and other projects, Cellar. And also Mark Reinhold, that is the chief architect of the Java platform at Oracle, and he's doing a lot of conferences, videos, and appearances, trying to convince people to use Jigsaw in the future. So if you like Jigsaw, you have to read him. Here I give you some URLs that you can use to get more information, and also the last link is the Mark Reinhold talk in DevOps 2015 that we were at. Maybe it's a little boring, but you can get a lot of information. And then few books. The first two books are covering the design patterns stuff. The first one is the most famous one. It's created by the Gang of Four, that are the first and the main design patterns that we should use. Also, Martin Fowler has a book about patterns from the architecture perspective. Richard Holt has a book about OSGI in action. It covers getting started in OSGI and some advanced topics. Paul Baker released recently a book about modular cloud apps with OSGI that I haven't read it, but it could be a good point just to read, because Paul Baker blogs a lot of interesting ideas. Also, Hakim Nierbeck has an Apache Karaf book. This is a book about some concrete problems that you can face and that you can solve using Apache Karaf. And also, I give you two non-modularity books, but I give you that books because I love a lot those books. So if you want to read about science fiction, you can read them. And that's all from my side. It's what we say every morning, right? So hope you have enjoyed the presentation, and if you have some easy questions, please shoot me. That's all.